within a colony, there is a great deal of variation in size. And in fact, ants hold the record in the animal kingdom for the extent of physical dimorphism within a species, indeed within a sex. So intra-species, intra-sexual dimorphism, the record is held by, in fact, this Malaysian ant on the right side of this picture. Can you see that now? As the picture appeared with the head of an ant?
Yes, sir.
Very good. Yeah. So this is a picture of a Malaysian ant which has this world record of dimorphism. This picture is actually a scanning electron micrograph. It was made by a friend of mine, Mark Moffat, then at Harvard University. He is a somewhat mischievous person, so he took the largest member of the colony and put the smallest member of the colony on the head of the largest member of the colony, and then made a scanning electron micrograph. It turns out that the largest member of the colony weighs 500 times the smallest member of the colony. So this is the level of intra-species, intra-sexual dimorphism that you see within a species. And I'm very fond of telling my friends who study molecular, cellular and developmental biology that these two kinds of ants with this difference actually are produced from the same genome. Exactly, genome, but depending on the environment, the same genome can give rise to this large ant weighing 500x and this little ant weighing 1x. That's the power of developmental biology, environment, epigenetics, and so on. So social insects have provided opportunities not only to study behavior but to study cell biology, developmental biology, molecular biology, epigenetics. In all these areas, social insects are very popular to study. As examples today, and these are the wasps. The wasps, of course, as you know, are my favorite. Now, the special thing about wasps that I want to mention two special things about wasps. First is all social wasps. All wasps are not social. In fact, the majority are solitary, but many hundreds of species are social. All social, and the reason they're called is because they are big, not from wax bees, not from sawdust and termite do, not from leaves that any ant could. Amen. How to a process that is remarkably similar to how we would manufacture. They scrape cellulose, chew it up, add their own chemicals, and make it into a fine pulp, spread it into a thin layer, and dry it. And paper is exactly how we make paper. And indeed, it is paper. You can write on. And if you are brave enough to explore with the brilliant site, which I like to call a multi-storied apartment complex. Yeah. 3 layers of paper comb. So this is the ground floor, first floor, second floor, third floor, fourth floor, fifth floor, and so on. There are these layers, and in the hexagonal cells, in these layers, that's where the wasps rear their brood. Now, unlike the honeybees use their hexagonal cells for two purposes. They store food, which is honey, pollen, and they rear their young ones. Wasps only use it to rear their young ones, not to store food. The reason is very simple. All wasps are non-vegetarian. They do not eat, they eat meat, kind of meat they can get. They are even known to steal meat from butcher shops. Now, unfortunately, the wasps have not invented a refrigerator, so they cannot store food. They have to get their food every day afresh. And have few thousand hungry larvae and adults waiting for food. Every day they have to find the food required to satisfy the hunger of these. So honeybees have one kind of challenge, namely how to store food and how to protect it from theft. Wasps have another kind of food, how to find fresh food every day. So you can see that trajectories of evolution for these groups are governed by these kinds of features. Now, I do not study that wasp which builds a multi-storied apartment complex. That's a very, very aggressive wasp. It has thousands of individuals per colony, and it's very shy. It covers the whole nest with I study this lovely wasp, which I think is much more beautiful. And can you see the Rhopalidia picture now on my slide? I keep asking you.
Yes, I can. I am there.
In a little corner there. But okay, because there is some lag. Okay. So you will all agree that this is a beautiful wasp. You can see this is so beautiful. This is also a paper wasp, but it builds in it and does not cover it. You can watch every wasp. You can see the adults, of course. You can see lots of pupal cells with their caps are closed. You can see many larvae of different stages of development. You can also see eggs in some of the cells. You can see everything, and you can watch everything, and you can observe everything. So painful. And if you love the wasp as I and my students do, this is certainly worth having get stuck. But actually, when you learn how to work with, you can learn how to avoid getting stuck. It's only people who don't know how to deal with the wasp that really get stuck. If you are an expert in dealing with them, you rarely get stuck. So this is the species that I have spent most of my career studying, and in trying to understand the workings of the wasp society. Now, I come back to this question, can we understand an insect society? And as I said in the beginning, we don't take this for granted. We worry about it. We have advice from two different philosophers, which we always keep at the back of our mind. Heraclitus, the Greek philosopher, said, nature loves to. So it's wrong to think that nature is an open book. You just look at it and you understand everything. It is, nature loves to hide. And this statement from this philosopher who lived in 500 BC gives us caution. So we keep this always in the back of our mind. We must be cautious. We must not jump to conclusion. We must not think that we have understood everything. So caution is one pillar of our research. But then there is a more recent English philosopher, Sir Francis Bacon. He's under the torture of experiments, which means you can do experiments and understand nature. So Francis Bacon, we are steered with these two boundaries, and we try to understand the insect society steered by caution and hope. Now, people often ask me, but why? But why do you study them at all? Now, it turns out that insect societies are studied for many different reasons. As I said, they are good model systems to understand behavior, to understand evolution, to understand molecular biology, cell biology, developmental biology, epigenetics. But they are also practically very useful. Honeybees are extremely important in pollination. Termites are extremely important pests. Ants can be pests. Ants can be serious pests in some part of the world. So they are practical. But even more interesting, there are lessons that actual practical lessons that we can learn. By understanding their methods of communication and social organization integration, people have drawn specific lessons for human communication. For example, there is a whole field called ant colony optimization, and this is a field which actually provides algorithms which are used in computer programming, in the management of the internet, in telecommunication, even in the distribution of cargo by airlines. Their social organization has been used to understand human groups can work. There are many ergonomic lessons that. So there are many reasons why people study insect societies. One of the reasons why this society is very different from all this, it's somewhat more philosophical, and that's what I want to emphasize today. When people ask me, why do you study? My answer is that for the same reason that an anthropologist studies humans. Why do anthropologists go and study some remote human tribe in some island with great deal of effort? That's because I think we would understand. Now, anthropologists can offer us a glimpse into the lives and mores of so-called primitive and exotic human societies. We use these terms because we are very different, but we don't really mean they're primitive. But I think that biologists can do much better. They can offer us insights from a whole range of animal societies with millions of years of evolutionary change. If you only broaden your mind and recognize that there are tens of thousands of species which have elaborate societies, then you're much greater for you to understand. And those of us who have the pleasure of studying insect societies can hope to harness wisdom from an altogether different subkingdom of life. That is even better. And the operative word here is wisdom. And I think what we need is wisdom. And I'll come back to this in the end. The reason why we study insect studies, not to imitate them blindly, but to get some kind of wisdom. And I'll come back to that in the end. But people are often perplexed, especially those who do more reductionist science in the laboratory. They say, but how do you study these wasps? What do you actually do? And actually it turns out it's not very difficult to study them. I already said I've chosen a species where you can see everything. So that's step one. And of course, all the wasps look alike. And what we can do is we can mark every wasp with colored paint spots. And we can do this in such a way that thousands of wasps can have unique identities, and then we give them a name, and then we follow that individual, and then actually a whole different world opens up. When you begin to see which wasp is doing what to which wasp.